Welcome. Welcome, especially those of you who, after celebrating with Trombone Shorty, I hope my voice is still here. That was fantastic. My name is Z. Smith. I'm Director of Sustainability and Building Performance and also Principal at Escudumas Ripple here in New Orleans. And it's my pleasure to welcome you to this session, High Performance Through Post Occupancy Engagement, 4 Firms Go Deep. There'll be a clicker, and I'm in the driver's seat. So the learning objectives. What we want to be able to talk about are the issues about the gaps between predicted and measured energy performance and what diagnostics can help us figure out why that's happening. We'll learn how to conduct indoor environmental quality surveys using an incredibly cool new tool, separating out performance issues attributable to occupant choice from those due to design and construction, and how to construct experiments on projects that verify the success of design choices. Not just about occupant satisfaction, but even onto whether something like a collaboration space actually promotes collaboration. So our speakers today, I'm welcoming you here from our home in the beautiful city of New Orleans, the city from which more round-trip tickets go with the return part unused than any other city in America. Then we'll move on to Lois Witt-Sale, the Chief Sustainability Officer of White & Company. Jim Hanford, an associate with Miller Hull, and then Andrea Love from Payette in Boston. So, my hero, Hercule Poirot, the great detective moving the little gray cells on a mystery of the mysterious gap between prediction and performance. We all know about 5 years ago when the New Building Institute published this study showing the difference between 100 lead buildings, what the energy model said in energy use intensity, that's the total amount of energy, gas and electric used, all converted to BTUs per square foot of building construction, what the model said versus what was observed in the first year of performance. And of course, the scary thing for those of you who remember your college statistics is the correlation coefficient in this chart was 0.33, which means to say that design choices, what we all live and care about, are responsible for 1/3 of the variation in measured performance. The 2/3 of the variation in energy performance in buildings was due to something else. So what's the something else? Well, it's like a good Agatha Christie novel. There's so many suspects, and we gather them into the drawing room. It could be the architect made a bad design choice. The engineer made miscalculations. The energy modeler could have modeled something that's not exactly what the building was. The contractor, amazingly, might not have built what the construction documents said. Manufacturers might have made a piece of equipment that doesn't actually perform in the way that their spec says. The building operations staff may have said, this ground source heat pump is just too complicated. I'm going to put it back and run the natural gas boiler. Or then there's always those pesky occupants. So when trying to understand why buildings don't perform as we expected, it's good to remember the Anna Karenina principle, that happy families are all alike, but every unhappy family is unhappy in its own way. So we have to go through and understand this gap by looking at all of the different ways that buildings can be at variance with what we expected. So there's this great study from the Toronto Public Schools where they looked at 50 schools built over the same 10-year period, pretty much to the same budget, pretty much to similar floor plans, obviously in the same climate, and yet there's a 3-to-1 variation in energy use per square foot. When the principal of the worst performing school was told that that was her school, within 6 months, she had moved to the middle of the pack, not spending any money. It was just she didn't know. And so this notion of providing feedback to people to just know that my utility bill is not high just because, that the utility is screwing me. The utility is high, we've met the enemy and he's us. And we have the power to take some of those things back into our own hands. We have one of our proud projects that's actually on a walking tour tomorrow, 930 Poydras. This is not a LEED certified building, but is for us the Hubble Space Telescope of building occupancy patterns. There are 250 apartment units in this building. This is one building envelope, one mechanical system, and 250 individually metered and individually read each month by whichever EDR employee pulls the short straw, electric meters. And from this, we can understand the variation due to choice versus how's the building doing. So as you can see, this is a bar chart showing the number of apartment using with a certain energy use intensity. There's somebody way out there who may have a grow-op in his apartment. Somebody down at the other might be just a walk-in that they only come on weekends. But there's this a nice spread. It's this huge 3-to-1 spread that we often see. And yet, the median of this distribution shows us that this is a pretty good building, sort of 25% below the average multifamily apartment building in the Southeast. But so there's this distinction between how good's the building and how good are the occupants. But on the other hand, there are other things where it's so often the building operations system and those helpful manufacturers. This was actually our firm's first lead project, opened back in 2006, and for the first month and a half was a great performer. The upper red line is sort of the baseline building. The lower red line would be sort of levelized, what the model had said. And then what happened was at month 2, the building systems software company said, you're going to love it. We have a whole new release of the building automation software. Here, let me install it for you. They overwrote all of the commission settings in the building. So the building energy use doubled. Now, the owner called up the commissioning agent, who was based about 1,000 miles away, and said, you know, these bills are a little higher than I was expecting. And the guy said, I will come down for free and do that. Can you spot me the airplane ticket? And the owner was a government agency. Said, we have no money, travel budget, to fly people in to do things, so we can't do that. So for a year, they endured high energy bills. And then they found that they had an IDIQ contract of a local energy rater, a guy who did like home blower door tests, who came through and said, well, I'm on the contract. I can do this for free. Here, let me adjust things for you. He adjusted the set point temperature of the air supply. The energy use shot up again another 50%, and that's when the mold bloom happened. Now, after the men in the bunny suits got through cleaning off the mold off the walls, they found the $300, flew the guy down, and saved $100,000 in energy bills. And ever since then, that building has been performing actually better than the energy model said. So this is like, you know, for want of a nail, the shoe was lost, and for want of a shoe, the horse was lost. Very simple things, head-smackingly stupid, but making huge changes, and one of the reasons we often see that buildings don't perform as we'd expected or predicted. So ever since then, at our firm, and at other firms now, we are fanatical about staying connected to the building during that early launch phase and kind of shakedown as the building maintenance crew, the operators, and the occupants get used to how it works. This is a visitor center and research lab in Apalachicola, where the upper dash line is the upper blue line is the minimum code buildings. And then what the computer model said, it predicted maybe 20% savings. And during those first 4 months, again, we found a plethora of, even in a fully commissioned building, of people misunderstanding how things were to work and just getting used to stuff. And if you had just been sort of passive about it and just accepted what was happening, you'd just say, well, those designers must have completely screwed up. But in fact, after that 4-month process, the building ever since then has been actually performing much better than the energy model said, due to a high level of occupant engagement. Now, we're very proud. On our tours, I hope some of you had a chance to go out to the Make It Right neighborhood and see some of the projects there. We're very proud when Green Source Magazine called us up and said, you guys win. Your building, your design, is the best performing building in the whole Make It Right neighborhood. It's pretty much net zero. Great. And we said, that's wonderful. And then we said, well, actually, you know, they're building multiple copies of our design. Let's go check the next one that they built. And so we said we must be geniuses, but then when we checked building number 2, we must be idiots. It's the second worst building in the Make It Right neighborhood. And we said, so what's going on? So we instrument the building for temperature, humidity, CO2 levels, all kinds of things. And what we found was the occupant in that second building, it was a very heavily used building. He lives in there. He runs a business there. His 2 adult sons are there. His grandkids live there. So a very high occupant use, and that's fine, and that's great that we're getting intense use out of a building. On the other hand, the student team that I was working with from Tulane University came by and said, well, actually, the CO2 levels are up at 2,500 parts per million on some days. And I said, well, that's a bit strange. And so we went and we looked, and we thought there must be something with the outdoor air unit malfunctioning. And they said, well, actually, on this one, it just draws it through by, a Venturi effect. And we opened the door, and the HEPA filter was completely clogged. And we said, have you never changed the air filter in the 2.5 years you've been in here? And he says, well, I looked, and those are really expensive, those HEPA filters. So I had this buddy of mine who works in an auto shop, and he rigged up this extra filter that I put over the return air grill. So he had 2 air grills sucking in series, trying to draw fresh air through as the system circulated. The AC system was running continuously, trying to keep up and deliver cooling. So his energy use was too high, and his comfort and air quality were bad. Once we sort of gave him a CO2 meter, showed him how to do it, found a supplier, an affordable supplier for a HEPA filter, suddenly the energy use went down, the air quality went up. And so he said, well, nobody ever told me before. And so this notion of engaging it, now the Make It Right folks are working really hard on engaging with all of their users so they understand what they're working with. So what this finally speaks to is the notion that often architects talk about the design process as they're talking about their baby. They're talking about this great thing that's going to happen when they're designing their great new building. And just like when your kid is born, having the kid finally be born, there's a pain right at the end of the sequence. My wife tells me that achieving substantial completion on our baby was painful. But you wouldn't take the great pictures of the newborn and say, that's great, I'll see you later, right? That would be completely irresponsible. And yet, as architects and as designers, that's often what we do, right? And so what we're trying to do at our firm and what the other folks here are starting to model this behavior is seeing the design process as really a long-term relationship. Because the good stuff happens after they're born. The interesting stuff happens after they're born. It's the stuff we get to learn from after they're born. So for our next speaker, Lois Vitsail, Chief Sustainability Officer of White & Company.
Thank you. Hi, everybody. Okay, so we're going to use a live experiment. We're going to talk this morning about a new tool that we've designed, which is really designed to assess comfort in buildings. We started this development of this mobile app, and here is on the... Yeah, hang on a second. Whoops, I'm coming undone. We have the... Thanks, Emily.
There it is.
Okay, so this is
I've never before at Greenbuild.
So this is it just launched in the Apple Store yesterday. This is a free mobile app that is available for download to assess the indoor comfort of our spaces. At White & Company, we use it for two purposes. The first is to be able to assess how good our designs are as a post-occupancy evaluation tool. Because as architects, we often go and look at our buildings and say, how are the aesthetics, how are the users using it, how's the energy efficiency, but the comfort parameters are rather invisible. And to encourage our own staff to begin to think in terms of the efficacy of the lighting, the comfort of the spaces that we were designing, the acoustic properties of the spaces we were designing, we decided to work on making this visible by creating this survey tool. So, but I have to tell you that this is a metered tool. So these are going to give you the observed parameters, not the subjective ones. So as we're going to actually meter this space in a few minutes. So I want you to consider these questions. Are you comfortable? Is the lighting level adequate, and are you comfortable visually in this space? And do you find the acoustics comfortable from a background level? I hope you can all hear me, and that I'm contributing to your acoustic comfort by projecting enough for you. So just think about those questions as we move forward. So we had started this with interactive Adobes, and we were telling our clients we could do these surveys mobily, and they kept saying, yeah, but we were really just filling out interactive Adobe sheets, and we really needed to take the next step and get it to an app. So we've been through a process of actually creating this, and it's for use on iPhones and iPads, and it's listed as the Indoor Environment Comfort Evaluation. So what we're measuring in this tool is we're measuring temperature, humidity, carbon, daylight, electronic lighting, and daylight. Now I'm going to bring up this app, and we're going to just walk you through this as we talk you through the tool. Now, in the app, for each range, we have created, for each one of those parameters, a range that's considered comfortable. And we've used the following benchmark tools, which are also listed on the app, so you could see what the parameters are. And in each range, this tool right now is really most efficacious for classrooms and for office settings. So those are the ranges that, according to ASHRAE and IES, are listed as within comfort. You will need meters in order to fill out the survey. So we're going to do a test right now. And with me today is my colleague, Emily Cataccio from White, who worked with me on developing this app. And we're going to name a survey. So let's call this EC13, since this is the session we're in for ease. And we're going to select we're going to select summer because it's not winter conditions here. And now we get to select which parameters we're going to measure. And so we're going to measure acoustics together. We're going to measure temperature, humidity, and CO2 levels in here, which will be a good indication of whether we've got adequate ventilation. We're not going to measure daylight, because there ain't none. And we're not going to measure electric light because we're in a performance kind of scenario, and it's really not going to be a valid test. So we don't want to measure that. So we've turned off those parameters. Now I save the parameters, and now I get to go into the survey, and I get to add a room. So in the room, we're going to call this 343/345. The type of the room, we're just adding in for our notes as an auditorium, and I'm hoping I spell it right. The floor is the 3rd floor. It automatically puts the date that we did the survey and the time, and we're going to note that it is an occupied space. So, Emily, who has our acoustic survey meter? Can you shout out what the reading is we're getting? And I have to be quiet while we do this. And don't talk over the mic or you'll get that reading.
It's still fluctuating. 50, well, it's going. That's me now. Okay. That's about 41.
41. That's 41 decibels in the background sound. So I add 41 in here. Okay. Now we're going to measure temperature. So who's got the temperature?
Over here. Back here.
Okay.
71.1 degrees F.
71. We'll round it out for those numbers. Now, we normally ask for 2 locations for temperature because, as you know, temperature can vary in a space pretty dramatically. And if you're in a room that has windows, we suggest that you measure at the exterior wall and then at an interior wall to make sure that you've got a balanced temperature across the space. So, but since the 1 meter has all 3 metrics, let's look at the humidity level.
53%.
53%. Okay, and these are in comfort ranges. And the CO2, please.
A very poor 947.
947 is a failing number. So what you need to know is that in each one of those ranges, CO2 so far is the only one that has been out of range. And so the ranges will say they're comfortable or they're uncomfortable. When this tool will amalgamate all of the different readings, and it will determine whether the space in general is comfortable, which means all ranges are within, all readings are within range. Marginally uncomfortable, which is when 1 or 2 of the ranges are out of range, and if more than 2 are not comfortable, then the space is listed as uncomfortable. Okay, so let's get that second temperature so we can finish this.
Second temperature is 71.2.
Wow, pretty consistent. Okay, thank you. So we don't have tasks, we don't have general lighting, and so in an observation we could just say occupied. Presentation, and we could say something like 50% full, right? So we get sort of an idea of what the occupancy is. If I can find my percentage, and then I can say, I can go here and I can actually take a picture. So I'm going to take your picture.
Smile.
So I can either take a photo or choose a photo. So everybody over here say cheese. Okay. And I'm going to use that photo, and it's going to populate into the survey. Oops, I'm sorry. I keep getting this disconnected. Hopefully it'll come back in a second and you'll see it. There it is there. And then I can hit save, and that is going to tell me that I'm uncomfortable. So I must have been out of range in 2 of the parameters, or more than 2 of the parameters. And then I'm going to show you, once you've done multiple, I can do many, many spaces and keep adding in new rooms. And it will, you can export to a PDF at the bottom of this, right here on the bottom of your right screen. You see PDF, so you can export that. It will put out a handy PDF that will summarize every single space that you surveyed. It will tell you what the overall comfort level was. It will import the observations that you typed on the bottom of the form. It will tell you what each of the readings were and if they measured comfortable or uncomfortable. And then it will summarize all of the spaces that you surveyed and give you a handy sort of summary of the spaces, which you can use to take to your clients to show your design team how'd you do and to learn for and about. And we take this to our clients often on assessments tools and say, okay, so you may have 20 years left in your HVAC system, but you're not delivering adequate ventilation, and therefore you need to make an investment here. And it really helps them see what the performance issues are. So please download the tool and use it. We hope you enjoy it, and we hope that we find it useful. Thank you.
And next, Jim Hanford from Miller Hall Partnership.
So this is going to be a little bit different, and I think one of the things we're trying to do here is show the different types of activities that designers can do that can be considered post-occupancy evaluations.
If you click advanced, it should do the right thing. Oh, go one more. Great. Can we get the B slides back up?
Perfect. Thank you. So 5 years ago, our firm decided that we needed to better understand the performance of our built work, not just in terms of the quantitative aspects, but also the qualitative. So we did a couple things. We started collecting energy performance data on as much of our projects as we could find, and we started to develop a program to develop qualitative studies around the design success of our work. The third thing I'm going to talk and end with today is user surveys, which was not initially part of our program, but is now becoming obvious to me that it needs to be. We started looking at energy performance data because it was important to us as a firm, because we thought it would be fairly easy to get our hands on the data, and that there were also benchmarks that we could compare our work against. And this was also around the time that the New Buildings Institute report came out that Z mentioned. And so we were inspired by that to kind of really find out how our work was performing in terms of energy. This is, we have a database of 30 projects dating back 20 years, definitely focused more towards more recent projects. These are the best, kind of the best data set. 22 buildings are represented here. And what you see is a couple high-performing or high-energy use buildings. This is EUI on the vertical axis. So there's a couple high energy use buildings. Those are teaching laboratories, higher education teaching labs, which are known to be high energy users. So let's take those out of the mix for a minute and look at the more typical buildings. And what we found was we have some high energy use buildings, like I mentioned. These are probably in need of some sort of remediation. They tend to be older projects. And we also have some very good performing buildings at the low end, including one that is currently operating at a net positive, and that shows the kind of power of specific targets around net zero energy and complete buy-in by the design team, the ownership team, and the tenants. The median EUI is 73, which is less than the national average, which is good. It's less than the regional average of 90 EUI, so we felt good about that. But there's a mixture of building types, so there's office, there's public, there's private, there's education. So if we look at the energy performance versus the project-specific baselines or the energy savings over a target finder or CBEX baseline, again, we see a distribution that has some bad energy performers, some good energy performers. The bulk of the data is between 0 and 40% energy savings. A median is 16. So on average, we're providing code-level buildings to our clients. And while we may be reporting for 2030 commitments, something between 0 and or 40 to 50% energy savings, maybe 60 in 1 year, on average over the last 20 years, the average is really 16%. Hopefully things are getting better, though. So if we look at these data points by year of completion or year of occupancy, we see that there's a few that are actually meeting 2030 targets in practice. And in general, the trend is up. In fact, the trend is going up. If we put a regression line through that, we see that it's actually increasing at 6% a year. But there's a couple data points that are probably skewing it. There's the low data point on the far left and the high data point on the far right. So is the data set robust enough if we take those out that we get the same answer? And the answer is no. It's actually increasing at a much lower rate, and the scatter is much bigger. So the R squared is 17%, which means there isn't really a very good correlation even between year of construction and energy performance. So, but there does seem to be visually a connection. So let's look a little bit more in detail at a certain building type, the office building, which was probably the most typical and most well understood commercial building type. And we see these are organized, these are office buildings in this data set of 30 organized by year of construction. And there does seem to be a general downward trend. There's a few points that look a little different. The first bar is actually an early all-electric building that had ground source heat pumps. It was our first commercial building application of ground source heat pumps. And the next to the last bar is a building that's in a slightly different climate than Western Washington, so it's actually much colder, much hotter there, so HVAC loads are higher. So it looks like there's a general downward trend, and I believe that this is actually above and beyond kind of general improvements in energy codes over that time period. So if we overlay kind of improvements in ASHRAE 90.1, and what we would expect to see in terms of building performance over that time, it seems like we're actually getting better at a faster rate than ASHRAE 90.1. So design hopefully makes a difference, design and design intent. Everyone likes to look at measured versus predicted, so this is kind of analogous to the, are we getting the same slides on the center side, I guess? You guys aren't getting my B slides, but that's okay.
Hold on.
Anyway, let's.
There we are.
Oh, there we go. Perfect. So there's the New Buildings Institute graph of the LEED projects, and there's our own graph of our own work. We actually show, our projects show a much better correlation. The R squared of this regression line through these points of measured EUI versus predicted EUI is 90%. So predicted EUI is actually a good predictor of energy performance in these projects, but it also shows that they're performing on average 25 to 30% worse than what is predicted by the energy models. So we start to think about, well, they're operating the building differently than what we thought, or they're doing something wrong. But in reality, what we found is half the time it's because our energy models really aren't very good. So one of the things that we've started to do is to work more closely with the modeling team to ensure that what is being modeled is accurately representing the design intent and the owner's intent in the energy model, and thereby using it as a tool that's actually useful down the road in post-occupancy and not just as a lead point scorecard. The other aspect that I talked about, really the bulk of our post-occupancy work is a qualitative process where we use an interview system with building owners to gather data about the success of the design. So we have a standard format, a list of questions. We have a ranking system that we go through with them, and then we allow for kind of open-ended Q&A with the people that we're meeting with. So we go down, we meet with we have two interviews, one with what we call the design decision makers, so the people that we were with during the design process. and making the decisions. And then also we meet with the facilities operators and building maintenance personnel, so we get kind of more of a nuts and bolts aspect to it. And we get a lot of data. This takes about anywhere from half to a full day, and then we go back with these kind of piles of data and spend the next week trying to figure out, well, what did we really learn and how can we digest this so we can present it back to the design teams within the firm and also the firm as a whole. And so one of the things we try to find out about is, well, what's really successful about this project and what's maybe less than successful. So I took the 5 most recent ones that we've done, which the process has been evolving, so these are kind of the 5 best. And we looked at, well, what is reported as the most successful aspects of these projects. And these are 5 projects that are LEED Gold or LEED Platinum, have generally good energy performance, although significantly above what we expected them to be. But we do see that on all 5 of the projects, design was successful. People feel good about how they look and how they feel. Sustainable design is also successful in the majority of these, and then there's a few more project-specific things that are found to be successful. In terms of the least successful aspects, I think this relates back to Z's slide about the families. What was it? The good families are all the same, so kind of the most successful, and the bad families, there's a lot of variation among those things. So the least successful aspects tend to be very project-specific, and it's interesting that the usual suspects, we see acoustics, we see lighting controls, we see certain little architectural things that we do that we think are neat that maybe don't work out that well in practice. There's thermal comfort, audio-visual systems, and commissioning. The interesting thing to me is that commissioning and lighting and acoustics come up on every project, but they don't necessarily rise to the level of being the least successful aspects on every project. We also talk about sustainability and talk about what they see as sustainable about their work or about their buildings and how successful those things are and what they talk about when they talk to people about the sustainable aspects of their buildings. And so in these 5 projects, these are the things that are seen as sustainable. So it tends to be tangible things that they can point to. And there are things about energy. There's, say, PV, which is kind of a tangible expression of energy intent. But most of the things are not about energy, although they may be related to energy. So we did all this work looking at energy data, but is that what's really important to owners? It seems like it's not, and is that because we don't make a big enough story about it during the design process, or is it because they're just concerned about other things? I think one of the interesting things is of these 5 projects, one is an award-winning project. It's won many awards. It's LEED Platinum. But they have an M&V system that doesn't work, and they're actually using 50% more energy than what we expected them to be using. But that we have not been able to get traction on kind of fixing that M&V system and really figuring out what's going on there, because they're just so happy with their building that's transformed the way they do work, and that's not really an important thing for them. In fact, of all these projects that we looked at, there's really only one where energy has been an issue, and that's one of those higher education teaching lab buildings where energy costs are high because that's what they are for lab buildings, and it's a publicly funded institution, and they just don't get the budget to operate those kinds of buildings. So there was kind of a mismatch from day one there. I'm going to talk about one last thing, which is the building that I showed that's operating at net positive, which is being certified under Living Building Challenge. One of the things that we needed to, well, there's lots of things going on with that in terms of research about the building in terms of post-occupancy evaluation, like energy use and daylight performance and all sorts of things. One of the things the Living Building Challenge requires is a beauty and spirit survey to find out what people see about the building and what their experiences are with it. And so we administered this survey, and it came back very interesting that the top almost unanimous vote getter was the fact that we used a heavy timber structure, and people really respond to the wood and the exposed wood in the project. Of the next several items, most of them are about the design of the facade and the windows and the way the space feels in terms of those windows and the connection to the outdoors, the daylighting design, the glare control, the operability of the windows, the fact that fresh air and natural ventilation is actually a component of the energy system. So this is really positive data that we spent so much time in design and kind of transferring money from other aspects of the design into the building skin and the design of the building so that it could operate as a net zero building. And that's being validated by user experience, that's what is most seen as beautiful. So I think this tells me that our post-occupancy work really needs to involve this user survey as well to really support the kinds of decisions that we're making during design. And so that's one conclusion of our work. And I also think that we need to be working more closely with our owners to establish energy performance as an initial design goal and using our energy modeling to set targets that can then be achieved over time. And really trying to make those connections between the user experience and the decisions we make about that and how those can also support good energy performance in the work. Thank you.
Thanks, Jim. And now Andrea Love, Director of Building Science for PAD.
So I'm going to talk a little bit about how we've been using our projects to really verify performance in terms of design as well as operational performance. So we created a sustainability action plan about 3 years ago, as I'm sure many firms have done as well. And one of the things that we did was that we set a goal of doing some sort of post-occupancy evaluation for all of our projects, whether it's a closeout interview from a disinterested party to a full-blown surveying and measurements. But in that process, one of the things that we also started doing was sort of these targeted investigations where we figured out that we could use our past work to really answer some questions that we had during design. And so that's what I'm going to talk a little bit about. So one of the first things that we do is verify a lot of the performance targets. So this is sort of our toolkit, similar to Lois's, where it allows us to measure temperature and humidity, the acoustics in a space, lighting levels, both daylight and as well as electric, plug loads to understand how much equipment. We do a lot of research labs, and so that's a big component of energy usage. And then we have an infrared camera that we can use to look at the envelope performance. And so here's an example of some of the things that we create, where we can go around and measure different spaces to see. The red line is sort of the design target for the acoustics, and the green bars are a range that we saw. And so some spaces can sometimes be successful and some aren't. And so it allows us to start to understand why some spaces are achieving our targets and some aren't, by doing it at this sort of discretized level. It also lets us start to look at specific things that we might be interested in. So, for example, in this project, one of the things that we did was we created a task lighting fixture that was integrating into the top shelf of a bench, a lab bench. And so we spent a lot of time in development sort of creating how we get this LED light in and how it would work, what the control system would be. And we set very specific targets in terms of the lighting levels we wanted to achieve, both on the work surface as well as just sort of ambient levels. And so we could go through afterwards and measure to see did our light fixture actually meet the target performance. So on one side is with the task lights on, and on the other side is with them off. And so we can look at what that difference was.
We have a request for you to speak up.
Oh, sorry.
A little slower.
Yes, I'll try. One of the other things that we can use these tools for is to verify not just the design targets. So this was some measurements for a shading strategy. We took 3 different measurements and allowed us to see whether or not our sun shading system was working and performing as we thought. But the other thing that was interesting was, just like you can verify an energy model and is performance meeting that, we could compare it to our design models for the daylight simulations to see whether or not our models were operating as we were modeling it as we thought it would, and how accurate the modeling software was. And so we found that it was fairly aligned, actually, so that was good to see. One of the other things that we can do is look at the design assumptions, so not just the performance, but are certain spaces meeting the design requirements or the design assumptions that we had when we set out for the project. So we had this project that we worked on where, from some initial observations, as we started the project of the users, we decided to change the layout of the design of what was traditionally being done. So some of the spaces that were typically buried sort of in the center and the core of the building, we noticed that the users were using quite a bit now, that the research had changed. And so we decided to move those to the exterior to get more daylight to those spaces. In addition, that they were working in a lot of silos, and so we were trying to figure out ways to sort of foster some collaboration and more interaction between the different researchers. And so we used what we call a shadow study, where we went out and we spent a few days just following around the researchers. And so on the left-hand side, you can see those bubbles are where they're spending most of their time. And so you can see that our design assumption that where they were spending time did prove true, that a lot of their time was on these exterior spaces, and so we were glad that we moved them to the perimeter so they could get some daylight, as well as how they were interacting and moving through the space. And although there was an increase in interaction, they were still sort of siloed a bit, and so maybe we have a bit more to work on there with the different types of research. One of the projects that we're looking at, or one of the sort of research endeavors that we're doing right now, is trying to figure out what makes a successful collaboration space. As architects, we often like to put spaces into a project and say, collaboration will occur. Magic. And sometimes it works, great, and sometimes it doesn't. And we don't really go back and figure out what were those elements that were key in making a collaboration space successful or not. And so we started off with a survey that we sent around just internally to our designers on what we thought made a successful collaboration space, so we could kind of compare with what we saw in the field. And so we did some observations, and we're in the process of doing this right now. And so this is sort of a work in progress of, when are people using spaces? What is it? Is it being used at full occupancy? What time of day is it being used? Are we meeting those targets? What are the activities that are going on there? Are people using it as we expected, or does it differ? Are they using it as a group or an individual? And so we can start to look and sort of track by these observations on how people are using spaces and if this meets our expectations from what we set off in the beginning of the project. And how are they using these spaces? Are they spending time where we thought they would? Similar to the shadow study, are they spending time in the spaces that we thought they would spend time in, or are they using it in a different way than what we expected? And so we can sort of compare that to what our design assumptions were to really see what these key elements might be to really create more successful collaboration spaces. And then the last example that I was going to talk about was one that is very near and dear to me, which is thermal bridging. And it's something that we all, as designers, understand exists in our building envelopes, that there's thermal bridges, but it hasn't really been quantified very much and really understood on what the significance was. And so one of the things that we did was that we went to 15 past projects. We used our work not because we think it's particularly bad in terms of thermal bridges, we think it's pretty standard for the industry, but because we have all of the drawings, specifications, and submittals, and so we really know what's in those walls. And so what we can do is we can go out with our infrared camera and measure what the R value really is in those facades, compare that to what we specified and what we thought it should be, and start to see if we can try to identify where some of those thermal bridges may occur and how significant they will be. And so one of the things that we did in our was we started to identify common areas where we were typically seeing thermal bridges. So they're kind of broken into two areas. One is sort of general cladding support systems, so things like masonry walls and the shelf angles and the brick ties were a common one, to things like transitions and penetrations, where areas where we, as designers, seem to typically be failing in maintaining the integrity of the thermal envelope. So things like soffits and parapets, and whenever we're trying to change planes, we often get in trouble. And so just some of these examples of some of the things that we've been finding. So this one's looking at windows and the transition between the windows, how a window is supported and the wall system. We all know windows are inherently kind of a thermal bridge because they perform inferior to the solid wall, but just that transition and how it connects is very critical. So for this example, in a design we often like to push the windows proud to kind of make a design aesthetic or recess them. But what that does is that changes the plane of the insulation and often requires additional support. So like this one where we now need a steel tube and a plate to support that window that's been pushed proud, and you can kind of see how that's radiating the heat out to the exterior. We're in Boston, so we're more concerned about heat loss, and you guys are probably, or at least in New Orleans, people here are probably more concerned about heat gain, but we're typically more concerned about the winter condition. Another common area, one of the areas that sort of was performing quite terribly, and I should have mentioned previously the sort of number at the bottom, the 72%, that's how much less it was than what we expected the R value to be. So the R value was actually at an R 3.5, and it was supposed to be something closer to, R 12. And so it's a 70% less is the R value that was observed for some of these things. Foundation walls were one of the sort of worst culprits, just because we end up you may want that concrete to be exposed, and so we have foundation on the exterior below grade, then it goes under the slab, and then it turns into interior. And so you can see if you look at the diagram of the blue, which is highlighting the insulation, that's sort of going all over the place, and there's a lot of discontinuities in the insulation. And so that's one that we've observed to be quite poorly. Another one that is, performs quite poorly is that we observed is curtain walls, and not just the glass portion, but the spandrel panels, because we often push the insulation to the back to have maybe like a shadow box, and you have a metal back pan that then ties in to the window, and so you have this metal that's undermining the performance. And this project even, they thought they'd be clever, and so they put spray foam insulation in the mullion because they're like, okay, we're going to really try and make this work. But the problem is you still have the metal of the mullion going through, and so it actually made no difference. And still performs about 65% less. The R value is about 65% less than what we anticipated. But the nice thing about doing multiple projects is that not just you see all the bad examples, which there are many, trust me. There's some good ones too, but you can start to learn about what things you've done in design actually make a difference. So these are 3 existing buildings, masonry buildings. We're in the Northeast, there's lots of them, where we kind of handled how we were going to put the insulation in 3 different ways. So one, we'd put the insulation between the studs. Now, I think hopefully you guys all know that that's going to be a big thermal bridge because we have the studs going through. So the stud was going through from the gypsum board to the masonry. With the second project, we just pulled it back just an inch. So there's still quite a bit of insulation between the studs, but there was just an inch of continuous insulation. And so, you lose a little bit of interior space, usable space, but the performance, it went from, these are sort of reversed, I should have switched them, sorry, I apologize, but the first one, the R value was about 46% less, or 46% of what we thought it should be, so there's a 64% reduction. The second one, you only lost about 16%. So that 1 inch made a huge difference in the thermal performance. That just 1 inch of continuous insulation really made a big difference. And the last one, it was completely separated, so that, we had a very thick wall. So if you have the interior space to do that, obviously it performs the best. It was at about 98% of what we thought, which is fairly close. But just that 1 inch made a big difference. And so it allows us to start to compare between different design approaches to really understand the impact on performance. And so those are just some examples. We have a report that's going to be out on our website November 1st if you're interested in, or a slightly depressing story perhaps. It has over 50 details in it of different ones that we've looked at. And we tried to not just depress you, but we also tried for many of the different systems to have improved examples so through thermal simulations on how we think we can do these details better. So there are both the good and bad examples of what we saw in the, built, as well as ways that we think we can improve upon it. And so hopefully, maybe in another 5 or 10 years, we'll have a new report that shows that all these improved details that we thought would work are performing much better. And I think that is it. We're open for questions.
Perfect. That's right. Thank you. Fantastic. So if you have a question, if you'd like to come to either of these stands. Yes, start with you.
I have a question. I'm Sarah Corbett. I'm from Charleston, South Carolina. And I'm an architect intern studying for those tests. Do any of your firms have in-house counsel? And if you do, what's the stance from your lawyers on doing research like this, publishing the data? Does it open you up to any liability? I work for a firm that has in-house counsel, and I think I know he would be really concerned, but this is the sort of stuff that we really want to do. Also, how do you structure this into your fee for projects, like when you start working on the fee with the owner? How does that work?
Great. Those are 2 great questions. So the first one, again, was what about the legal, if we, as my mom said, if you look behind the refrigerator, you might have to clean there, so don't look behind the refrigerator. So it's the legal implication of if you start looking at how the buildings perform and they didn't perform as good as you said they would, are you exposing yourself to lawsuits, et cetera? And the second question was, how do you get paid to do this stuff, right? I just want to applaud, actually, Jim Hanford, who's the most out there. I mean, we're talking about, at the last couple of green belts, we've all talked about material transparency, and I think what you're seeing here on the stage is people who are talking about performance transparency. And especially the way that Jim was laying it out, I just want to applaud the level of transparency that his firm is out front on. Luckily, they have some great performers that provide a kind of shield
that
for
helps,
the stinkers. But why don't you start? And I have some observations, too.
We quickly talked about the legal issue at the beginning, but we got past that pretty quickly, and I actually don't even remember what we decided. But it was a level of care. I mean, it's really, we felt like we would probably be taking on as much liability by not doing something as we would be by doing something. So I think we got past that pretty quickly. Mm-hmm. As far as getting compensated, we've talked about that a lot. And one of the things that we haven't been compensated for anything that we've done, but we are looking at doing some more kind of better reports that owners can use for kind of PR or whatever. And so we're thinking of establishing kind of a format for that and a look, and then maybe marketing that and seeing if people will actually pay for it. Mm-hmm. We haven't gotten into any real kind of M&V like, energy model calibration and more involved work with detailed data, and that would definitely, I would recommend being compensated for that. Mm-hmm. So.
Lois, your work into this field, from my understanding, actually began because you were being paid to do a facility assessment. So maybe you could talk a little bit about how that turned into this other thing.
That's right. So since we often do renovation, and so as I said, you can use this work either for assessment or for post-occupancy evaluation. And we use it for both lessons learned and for initial assessment. And we have been paid by a number of school districts to do district-wide assessments of their spaces. I have to tell you that we usually pair it with an occupancy survey that's subjective, so we do in-space measurements to answer those questions we started with on that slide, but we have been able to get fee for that. On the post-occupancy, not so much, but we really think about it as our own test to see whether or not we're delivering the spaces we're designing. And let's face it, if we're not, then we need to go back to school. So I think it's a value. We need to figure out how to do it. And no legal conversation has resulted from any of it. We have had buildings that when we asked how did they perform and they weren't up to speed or performing as predicted, we just jumped in to help figure out why, because we wanted to know. So it would be nice to be paid for that, but and I think it'll happen coming out of AIA 2030 and all the sort of industry-wide questioning on post-occupancy evaluation. I think the AIA will help us figure that out.
Mm-hmm. Andrea?
Yeah, we don't have internal counsel, so maybe we didn't come to the right conclusion. But you
can slow down, Andrea.
Oh, sorry.
There's no timer now.
We had quite a bit of debate as well about the legal implications, particularly actually around the thermal bridging stuff. There was concern that we might open ourselves to a lawsuit. But what we decided was that this is industry standard. It's the standard of care, and we're just looking at it. Obviously, we don't publish which project is which because we don't want our clients to get upset if they find out that we have a poor performing facade for them. But we had quite a bit of debate and kind of came to the same conclusion that Miller Hall did, that we think it's better to know than not. And we also don't get paid in general for post-occupancy evaluations. We sort of build that into how we work. And we see that as improving our performance going forward. And so because we actually work a lot on similar type buildings, we see an advantage of spending some time to answer a question now that we know is going to come up in the future. And so maybe if you have a more diverse practice that might not be able to make that business case as much, but we see the benefit of spending some internal time to figure out how we do something right, because it'll pay going forward in future projects. And some of them have actually started to pay for themselves. Well, may not pay for themselves, but offset themselves a little bit. So like the thermal bridging project, we started just internally. Payout was funding for about a year. We were doing the research, and then we were able to get a grant because we had started to do this research from the AIA to continue the work. And so then we were able to get some money. Obviously, it doesn't cover all of it, but it offsets it quite a bit. So that was really helpful.
So we had a developer that we've worked with that we voluntarily did a post-occupancy study and found some problems and helped them remedy it. And then we said, we'd like to go wide and look at a lot of your projects. And they said, we'll get right back to you. And then what happened was one of their tenants was unhappy with the conditions in their building, and so their tenant's lawyer paid a company, a third party, to come in and do an assessment, at which point the phone rang and said, we'd really like to work with you and understand what's going on. And so I think we're seeing that it's sort of that, they say that Galileo, the people that developed telescopes and Galileo just kind of aimed up, right? And that when the tool becomes available, what then happens is people starting to apply it in new ways and what you learn from it. And I think that phenomenon is going on with these tools. The second thing I'd say, and so that standard of care shifts through us. We did talk to, not in-house counsel, our out-house counsel, I guess, about this, but they said, again, if you can know this and you don't look, that doesn't mean you're shielded. The second thought was one of the partners in our firm said 110% of our profits come from return customers, return clients, which means on a new client, when we're doing the first project for a client, we spend so much time learning about their processes and everything that it's often difficult to make money on that project. And so the most profitable projects that we have are customers that we've built a long-term relationship with. And so for the time being, we're carrying these costs as part of indirect marketing with client retention, and that's working out. The challenge with this part is that if you don't have the capability, for example, to do in-house energy modeling, when you're trying to diagnose what's going on, you may have that moral commitment, but your mechanical engineering firm may not. And if they're not willing, they say there's no fee for that, then you're kind of stuck and you might need to start switching to another mechanical engineering firm. Great, let's have another question.
I'm Shivani Langer, former SHW Group, now Stantec from Austin, Texas. And I just wanted to also point out we've done about 6 post occupancy evaluations on 6 elementary schools with different school districts all over Texas. And the way we kind of funded it was we had an R&D program that actually funded those. But then, having shown the results and what all we learned as architects and what all our clients learned, we have now actually been able to incorporate the money within our contracts for those same clients.
That's fantastic.
So they have actually seen the benefit of it.
That's great.
A bit, that we will be designing better buildings for them. I also wanted to say that I think as having done this before, I think the selling point for us has been that we have used third-party user occupant surveys. So I think they consider that as a big deal because they think that we are not going to be biased as to what we actually project to them. We're not going to say our buildings. And yes, we have figured really sometimes bad, occupant evaluation has been the most surprising, especially in terms of thermal comfort, I would say has been our biggest dissatisfaction. And then to that point, I think your tool, that I'm very grateful you are making it free and everything. I mean, that's just a big step forward.
That's great.
Yeah, and I think, I was just going to say that, hearing people being so dissatisfied with spaces that we thought will do great, and there's some amount of user personal, their own personal, what am I looking for?
Perspective, right.
Yeah, and then with readings you can say that, it's the same temperature as the other space.
I was going to say just very quickly, and I want to get one more question in the time we have. I think there's a tremendous, I don't want to say democratic power, but there's a power in surveying everybody because what we found is building managers and building engineers often, they think that complaint is the squeaky wheel and that everybody else is fine, they're doing it right, and just shut up. And so we had, in our own office space, we had a building engineer, a 30-story office tower, where we said, it's too cold. And they said, it's perfect. I said, no, it's too cold. And they said, well, we don't have the ability with our mechanical system, it's an older building, to change your temperature. We'd have to change the entire building, and we can't do that. And we said, okay. And then we did this survey where we surveyed every single occupant on the floor plate repeatedly over a course of multiple days, and then fed that information and showed a little map showing that 96% of the building occupants were too cold. And he goes, oh. And he changed it and was able to change the temperature. So there's this very condescending attitude you can get on buildings operations people about users and who they think complains. And I think that using the power of mass survey, improves your bargaining position.
So let me add a comment though. There is a question about a disconnect between metered results and surveyed results. And I don't want to suggest that if you just show somebody the metered results that you can say, but you got to be comfortable, because ASHRAE says you should be comfortable, right? That's not the end-all and be-all. I think we really do still have to figure out what the discrepancies are. We wanted to put airspeed into the survey tool, and we bought meters, and we tried to measure airspeed because, right, it can be 74 degrees, but if air is pouring down on you, you're going to be freezing cold, right? So it's not a one-to-one connection. I still think we're under the gun to really wrestle with this issue between perceived comfort and measured comfort. So please don't think of the tool as sort of the end-all and be-all.
Right. The people have amazing power. I mean, we're finding in our surveys, for example, ASHRAE claims there's no difference by gender. You know, it's all about CLO level and things like that.
Cool.
And it's baloney. Last question, because we're running out.
Yeah, hi, Jody Snitz-Anderson. I work for DASME, which is a state authority in New York. And I'm very interested in the connection to the user interface part of this. These tools are fantastic. But my problem is in the feedback from the users and their responsiveness to data and their responsiveness to how we use the data they give us. They don't want to complain and know where they sit, because then we'll always think that they're the complainers who know where they sit. And the other piece is related to the thermal bridging. I was interested in seeing, especially thermal bridging issues can affect comfort inside. It's hard to tell someone to replace a window, but if you say it's going to save a little bit of energy but also improve your comfort, that's a big selling point. I saw in some of the charts that your users were anticipated to be near the window wall, but more users actually used interior spaces. Have you done correlation between thermal bridging and airflow issues, radiant heat, that stuff along the perimeter, to how people actually use the space, and how can you use that to work with your occupants?
Yeah, that's a great question. And actually, particularly for the type of projects we do, thermal bridging manifests itself more as a thermal comfort issue than necessarily energy issue, because research labs are so energy intensive in all sorts of other ways that the impact of the envelope can often be rather small. But it is a comfort issue. We have observed anecdotally, when we do a survey, we do try to ask whether or not someone's sitting next to a window versus more of an interior space, so we can get that difference. We've been doing, just to continue on this research project that we started with thermal bridging, to understand, sort of what the impact is. It actually, the thermal comfort from the, what we found is that it's really driven more, even when there's thermal bridging, it's driven a lot more by airflow, as you said, and the windows, because even a good performing window is still bad than our poor performing wall. And so we've been trying to understand that issue better, because that is really where a lot of it has a small energy impact, but that's really where it comes into play. But we're just still trying to work on that. So we do try to figure out the difference when we do the survey.
And I did want to do a little pushback, though, on the idea of anonymized surveys. I think anonymized surveys are great, and they'll tell you one set of data. They'll tell you something. Other surveys, it's interesting, there was someone I was taking up the other day, when they do comfort surveys, you should always include a question of, and this is really scary, you have to anonymize it to ask this question is, do you like your boss, and are you satisfied with your salary? Because often, there's I'm generally unhappy, and therefore I'll take it out on the comfort survey. And so, being able to control for that's important. On the other hand, we have found in some of our work that when we spatially map comfort, we actually learn things about our building envelope. We learn where there was an air infiltration leak, or where there was actually a failing mechanical unit. And so what I like to say is we have the most exquisitely sensitive building automation system imaginable. We have the building occupants, the people. And if we would just trust and provide a mechanism, you have to provide a kind of safe way of handling that. But if we harness that power, it's even more powerful than the iPad or the iPhone in everybody's pocket. It does lead to the idea of, Democrobus, where everybody gets a steering wheel. If we could have buildings through either personal environmental controls or other systems to allow variation due to people's variable sense of comfort, that would be helpful. But even when the mechanical systems can only sort of blanket areas with given, say, temperatures or acoustic levels and so on, getting that spatial information, that's gold. And so we've got to find safe ways to get that information while respecting people's privacy. Thank you all very much.